All right, looks like we are live. So let us get started with it. All right, to convert the AC voltage from the armature to DC voltage, DC generators make use of a commutator. So this is the main difference between an AC and a DC generator, is the commutator. If you remember the slip rings from the last one, the commutator is like a slip ring, but it is split down the center, and the brushes are like 180 degrees away from each other, so that the two brushes are never touching the same spot on the or the same side of the commutator as it rotates. All right, next up. Maximum voltage is induced into a conductor when it cuts the magnetic field at, this one is 90 degrees. If you look at, let's open up Paint one more time. If you look at your pictures of the, so let's put two squares. I'll make this the positive and the negative. All right, you have, oh, this is still line drawing. Oh, wait. I have an arrow tool. You have magnetic lines of flux going from one to the other. As your wire goes around, let's do a new color, purple. As your wire spins, you know what? Let's remove my drawing skills and just do a good old circle. As your conductor spins in here, you have 0 degrees, 90 degrees, 180 degrees, and 360 degrees. So having that, whenever these, wait a minute, that's not 360. My mistake. This will be 270. Okay, 270 degrees. At 90 and 270 degrees, it is traveling through the most lines of flux that it possibly can. At 0 and 180, it's going through the minimum amount of lines of flux. So that's the process right there. It spins around and around, and that's it. At 90 and 270, it's creating the most voltage it possibly could. All right, next question. The wires connected to the brushes of a DC generator are usually marked. Brushes on a DC generator are usually A1 and A2. This is one of those little bits of trivia that you'll need to open your book up for this one. And it'll just tell you whenever you're reading about DC generators. Okay, which type of generator is represented by the figure below? If you had to take a guess, it goes from one, has to go through both things, That is a series generator because the components are in series with each other. All right. Next up, another name for an AC generator is the alternator. So now we are into the AC part of the lesson. Yes, another name for an AC generator is an alternator, which is weird because your car runs on DC and has an alternator. I think that the alternator in your car is rigged to output DC in the long run. Which of the following factors helps determine the frequency of an alternator's output? Largely it's the speed of rotor rotation. The rotor won't have a magnetic field generally. Alternators do not have commutators. And there's probably not wire turns on the stator pole because the wire turns will be on the rotor and the magnetic field will be the stator. Alright, the primary difference between a simple DC generator and a simple AC generator, so the primary difference is the commutator, and the AC generator has slip rings. So DC has a commutator, AC has slip rings. The two basic types of alternators are the revolving armature type and the revolving field. So either the armature spins or the field spins, depending on the size of the generator. At a certain size of generator, it doesn't make sense to spin the coils because they're just too big, and it makes more sense to spin the magnetic field. Large capacity generators are usually enclosed in a hydrogen atmosphere. So all the moving parts will be closed and you'll just have the leads come out of it. Three-phase generators have three windings placed 120 degrees apart. If you place three windings 120 degrees apart, that gives you 360 degrees. And if you look at the sine waves for three-phase systems, the sine waves start 120 degrees apart in their rotation also. So that all ties together. Oh, we got a few more minutes. I'm going to finish up this live stream. I will see you guys in roughly an hour for the last live stream of the day. Alright, bye. Oh, my